I'm thinking fractions.
Fraction.
Yeah, fractions. Good, you got it. So we're going to get rid of our fraction first. Because when there's parentheses and fractions, you pretty much always want to start with the fractions before anything else. All right, and if I'm getting rid of my fractions, what should I do to both sides?
Multiply by the new denominator.
Good. We're going to multiply by the denominator. Since I have a 2 in the denominator, I'm going to multiply by 2 on the left. And then on the right, what's going to be very important on the right? Do I multiply 2 times 9 only? Or do I do 2 times both of those?
Times both.
Times both. So it's kind of like if we have parentheses. So I'm going to add parentheses to make sure that I distribute the 2 to both of those terms. So on the left, I'm all good because I just got rid of my fraction. And I'm just left with 8x minus 6. And then on the right, I'm going to multiply everything by 2 in order to continue. So I have to do 2 times x. Well, that's just 2x. And then 2 times 9, which is 18. Do I have any questions up to this point?
Yeah, I didn't see that part where you were doing at the beginning.
So we multiplied by 2 because we're always going to multiply by the denominator that we're trying to get rid of. Since we have a 1/2, right? We want to get rid of that 1/2. I have to multiply by 2. When you do that, it automatically is just going to get rid of the fraction. So I got rid of my fraction, and I'm left with 8x minus 6. But then on the right side, you have to multiply everything by 2.
All right, I get it now.
Okay, cool.
How did the numbers on the left not change?
Good question. It's because they're in parentheses. And whenever something's in parentheses, it doesn't get affected by what you do on the outside. It's kind of like they're hiding in a little house, right? Like they're not going to get affected. Very good question, because that can be a little confusing sometimes.
Okay.
All right. Now we got our fractions. We already automatically also got rid of our parentheses, so that's all good. So the last thing to figure out is how to get all of our variables to the same side. So what should I do here?
You subtract.
Good, I'm gonna subtract 2x from both sides. Why am I putting it under the 8 and not under the 6?
Each variable.
Good, they line up with the variables. If I'm getting rid of a variable, it has to line up with the other variable. So the 2x's cancel out, and now 8 minus 2 gives me 6x, and everything else stays the same. And now I'm almost there. I just have 2 more steps in order to get x by itself. So what comes next?
You add 6.
Good. Add 6 to both sides. 18 plus 6 gives me?
Good morning.
Good
24.
morning. 24, good. So I have 6x equals 24. Now I'm going to do my final step, which is to divide on both sides.
And then
4.
Good. Good job. X equals 4. All right. So this long equation, even though it is a little bit longer than most equations, it's always going to follow a step-by-step process that stays the same. So I just want to write down the steps we took really quick. So in step 1, what property did we use there, and why did we do it?
Multiplication?
Yeah, multiplication property. And we used multiplication in order to eliminate.
Get rid of the, yeah.
Good. In step 2, we used
subtraction.
good, subtraction.
calling Michelle.
We use the subtraction property in order to get the variables to one side.
But they are spelled almost, no, they're not.
Do you see it? they started out, I had variables on both sides of my equals, but then I brought them over all to the left side. Then in step 3,
Subtract again.
we didn't
Oh,
subtract.
I mean add.
Addition.
There you go, addition property. And what was the reason?
To get rid of the -6.
Good. And that -6, because it's all by itself, we call that a constant. So we wanted to get the constant to the other side. And I'm running out of room, but what was my last step?
Division property.
Division property. And why did we divide?
To get the x by itself.
It's equal to.
Good, to get the x by itself. So let me write that down. Okay, so the 4 steps that we took, even though, you know, you are always going to get different types of problems, the steps and the order that you do those steps in will pretty much always be the same. And that's going to be very important for today's topic, because today we're going to be solving different types of equations. These are called literal equations, so make sure you wrote down today's topic of the day. And these literal equations, I'm not going to lie, they are going to look a little more confusing, but if you always remember, we're going to go follow these 4 steps, always the same types of steps, hopefully it's going to be a little more easy to understand. But before I go on to today, the first problem of today, I just want to make sure that I mention 2 things. Number 1, I put grades up already for your quiz that you took on Friday and the Khan Academy that was due on Friday. And you'll see that if you didn't do it, it's going to look like you got an F, because if you don't do something, I'm always going to put it in as a 0. If you turned in late, so let's say you had internet problems, you didn't have time, I completely understand. However, you have to tell me, because if you don't tell me, it's not going to give me a notification once you turn it in late. So I always get a notification when you get it in on time, but then after midnight, it's no longer going to tell me if you did it. So I'm not going to know that you did it. So I'm not going to go back and check, because I already checked when it was already due. So I didn't go back and check, and it's not going to show up in your grade book. So if you ever need to turn something in late, the most important thing is to tell me so that I can make sure that I go back and check your grade. Understood?
Yes.
Okay. So if you have an F and you're like, wait, Miss Lopez, I did it, you have to make sure you tell me. And then the other thing, reminder, is iReady. So I still have a few people who haven't finished their iReady, and you guys need to get it done by tomorrow, which means that if you did not finish yet, you need to get up early tomorrow and get it done at 8 in the morning when it opens up. There's no excuses. If it's not done by tomorrow, I will be having conversations with your families to make sure you get it done. So do I have any questions on that? Okay. All right. With that being said, let's go ahead and start. So we have one definition to write down, but you're not going to write down this whole entire thing. You're just going to write down the first sentence. And while you guys write this down, I'm going to go ahead and read this whole paragraph because there's a lot. So a literal equation, okay, literal equations are equations that contain 2 or more variables. Up until now, we've only done equations that have 1 variable. So from here on out, we're going to look at equations that have 2 or more variables. There are many literal equations in the form of math, science, and engineering formulas. These formulas may seem like they can only be solved for the variable that is isolated on one side of the formula. But by using inverse operations and the properties of equality, a formula can be rearranged so that a variable in the formula can be isolated. I'm going to highlight that word. You don't have to write it down, but we're going to define that word. It is no different than how equations are solved by using inverse operations and the properties of equality. So what does the word isolated mean?
But by itself.
Good, all alone, by itself. So basically what we're going to be doing today is we're going to look at equations that have a lot of different variables, and we're going to figure out how to get one of those variables by itself. So I put this rectangular prism here because the rectangular prism is one example of what can be a literal equation. So when you look at this shape right here, does anybody remember the formula for the volume? One.
Length times width times height.
Good. Length times width times height. So notice this right here is a literal equation because all it has is variables. There's no numbers, but it has the V, the L, the W, and the H. So you guys have already seen literal equations before. You just didn't know that they were literal equations. Can anyone think of another type of formula, maybe not for volume, but for something else that could be a literal equation? Think about the formulas you've learned before in other math classes.
The formula for a triangle.
Good, for a triangle. Let's write it down. And I saw, Alyssa, I saw yours in the chat, so we'll write that down too. So what's the one for a triangle? Do you remember?
Base times height divided by 2.
Good, perfect. 1/2 base times height. That's the area of a triangle. That's another perfect literal equation because it has 2 or more variables. Alyssa gave us the volume of a sphere. Is that what that is? Or is it the volume of a cone? I don't remember.
Here.
Okay, so that one is V equals 4/3 pi r to the power of 3. Looks confusing, but at the end of the day, that's a literal equation because it has more than one variable. So that's all. The only thing you have to remember is that a literal equation has 2 or more variables. And you're going to see a lot of different ones. So let's go ahead and go to the next problem. Or actually, before we go to the next problem, I want you guys to just write these 3 down. And these are examples. Of literal equations.
Wait, Miss.
Yes.
Is the third one? There's only one variable. Is pi a variable?
Pi is not a variable, but there are 2 more. There's V and there's R.
V?
The V at the front, that's a variable.
Oh, volume. Or
Yeah. All right. And in these 3 examples, notice, very important. In the first one, which variable is isolated? Which one is by itself?
V.
Good. V is isolated, right? Same thing with the second one. In the second one, the A is isolated. In the third one, the V is also isolated. So in today's class, what we're going to do is figure out how to get the other variables isolated. I see a couple people still writing, so I'll give you about 30 more seconds.
I took a picture.
Okay, you took a picture. Nice. And you can always take a picture, by the way, if you need to. Or if you need something at the end of class, I can always go back. All right. So let's stick with what we already talked about, which is the volume of this rectangular prism. So in this formula, I want the H to be isolated instead of the V. So I start out with my formula, or my literal equation, and I want to get H all by itself. We're going to use the inverse operations just like we did in the bell ringer. We're going to use the inverse operations to get it by itself. So let's think about it. Right now, what operation is holding the L, the W, and the H together?
Multiplication.
Exactly. They're being held together by multiplication. In order to undo that, in order to get rid of what we don't want, we're going to do the opposite of multiplication, which is?
Division.
Division, exactly. So in order to get rid, because I don't want the L or the W, I'm going to divide by LW. But if I do that on the right side, what do I have to do?
Do it to
On the left.
Do it on the left as well, exactly. And if you're wondering why I write the L like that, it's because if I write L like normal, it just looks like a 1. So if you ever wondered why they always make the fancy L, that's why. Okay, and what happens? Well, the L's cancel out, the W's cancel out, and I'm left with V over LW equals H. And even though my H is on the right side, this is the same exact thing as H equals V over LW. You can just flip it over. And that's it. So basically, this is obviously was just one step. We're going to definitely do ones that are more than one step. But all you have to remember is that you're basically solving it just like a normal equation. It's just that instead of numbers, you have other variables.
Like letters?
Yeah, other letters.
Okay.
Do I have any questions so far?
Miss, can you explain it again?
Yeah, of course. Yeah, I'll go back to the beginning. And if you already get it, good. Just hang out. So basically, always, first of all, we got to read the problem, right? And the problem says, in the formula V equals LHW, the variable H needs to be isolated. So it's telling us to get H by itself. But when we start off, right now, at the very beginning, H is not by itself. H is tied to the L and the W. They're all together in a group.
Okay.
Okay, and they're all together in a group that is using multiplication, because really it's saying L times W times H. Since that's using multiplication, in order to get at, we want the L and the W to go away, the only way to do that is using the opposite of multiplication, which is to divide. So all I did was divide on both sides by L and W. That cancels them out on the right side. So on the left side, I'm left with V over LW. And that's how I got my answer. Any other questions? Okay, cool. Okay, here's another one. Now, actually, before we do this one, sorry. Why do you think you might want to do this? Like, why would somebody want to write the equation the way that I finished out writing it this way?
Like to find the number or something like that?
Exactly. So the original formula is the formula for volume. So if you want to find the volume, you use that formula.
Oh, so like if you were to do that, you want to find like H, like height.
Exactly. So when you rearrange it, now it becomes the formula for height. So if you want to find the height, you could use the formula that I created. So that's kind of why we do this. It's in order to make it easier to solve a problem. So here's a problem. What I want you guys to write down, I don't want you to write down the whole thing. You guys are going to write down the formula and then everything else that I write underneath, okay? So just write down the formula. You don't have to write down that whole word problem. All right, so let me go ahead. Would anyone else like to read it? I can read it, but if someone else wants to volunteer, you can go ahead. Okay, I can do it. We saw big numbers and letters, and we don't want to read all that. Okay, so the formula for density is D equals M over V. Lead, which is a type of metal, has a very high density of 11,340 kilograms per meter cubed. Plastic foam has a very low density of 75 kilograms per meter cubed. The formula for density can be rearranged to solve for for V, volume, or M, mass. So in other words, it's saying you could rearrange this formula and isolate the M, or you could rearrange the formula and isolate the V, depending on what you want to find. So now let's see what it is that we want to find. So this is saying a sinker on a fishing line is made of lead. So that's important, it's made of lead. And it has a volume of 0.0000015 meters cubed. What is the mass of the sinker? So it's asking us, what is the mass? If we're looking for the mass, which of the three letters, the D, the M, or the V, do I want to isolate?
And
The M.
Good, exactly. So since I'm looking for the mass, I need to start off by isolating the M. So I start off with my original formula, and then I have to think which inverse operation should I use in order to get M by itself.
Multiplication.
Good, Samantha. We're going to multiply because right now, how are the M and the V related to each other? What's operation?
They're in a fraction.
They're in a fraction, and fractions are basically like what type of problem?
Dividing.
Division.
Good. So right now it's M divided by V. So the opposite of that is to multiply. So I'm going to multiply by V on both sides. When you multiply, that's how I eliminate the denominator. So on the right side, I'm left with M. And on the left side, I have V times D. And I can just write that like VD. And just like I said before, I can switch it all around to put it in the correct order. With me so far? Questions so far?
Nope.
Awesome. So now I have the formula. Now that I have the formula in the correct order, I can plug in my numbers to get an answer. So I need to plug in a number for V, and I need to plug in a number for D. V stands for volume, and D stands for density. So look at the question, and who can tell me what's the volume?
0.00015.
Good. 0.0000. Is that it? 1, 2, 3, 4. Yeah, 4 zeros and a 15. That's my, oh, I put it in the wrong color. My bad. Trying to color code everything to make it clear. There we go. So that's my volume. What's my density?
$75 kilograms.
Is it 75? Read carefully. What material is this talking about? Are we talking about foam or lead?
11,340.
Good. Okay, so we're looking, read carefully. This is talking about something made of lead. So if you go back to the beginning, it says lead has a very high density. So we're looking at the lead. So that's 11,340. All right, we've got our two numbers. Go ahead, use your calculators to multiply and get our answer for mass.
$0.1701.
Good. Does anyone want to confirm that?
Got the same answer.
Good. So, can you repeat it one more time so I can write it down?
0.1701.
0.1701.
01.
And anybody want to guess what the units are? Look carefully in the problem.
Kilograms? No.
Yeah, you got it.
Oh,
Kilograms.
wait, that's right.
Kilograms. And that's my answer. Any questions, comments, concerns?
No.
All right, cool. Take a couple seconds. I have to go get my computer charger from over there, so just take a second to look at it, and I'll be right back. All right. All right, let's do another one. We're going to do another very similar one. Would anyone like to read this one? It doesn't have as many confusing letters or numbers.
I'll read it.
All right, go ahead, Amani.
Using inverse operation to rearrange literal equations can be applied to any formula. The interest formula I equals part is another example of a literal equation. In the formula, I represents interest, P, the principal or the initial amount to which interest will be applied, R, the rate at which interest will be paid, and T is the time in years.
Awesome. So it's basically telling you what each letter in that literal equation means. So I equals PRT is it's an equation that you use a lot in finance and economics if you're trying to figure out how much something is going to cost if you put it in the bank or if you invest in something. So it's a pretty good equation to use, and it can be used in the real world for sure. So let's go ahead and solve this problem. We're going to find the number of years used in the calculation of a $1,000 loan at an interest rate of 5% with interest totaling 600. So it's kind of like we need to put all the puzzle pieces together. First thing I want to know is, what am I looking for? Let's highlight, what am I looking for? One.
The number of years.
Number of years. We're looking for the years. If my equation is I equals P, R, T, which of those variables, I, P, R, or T, represents years or time?
T.
T, good. You can go back to the question and look. T is the time. So that means I need to get T by itself. I need to isolate the T. Who can tell me how to do that? This is very similar.
Division?
Good, we're gonna divide. Since P, R, and T are being held together by multiplication, division is the opposite of multiplication, and that's how we're gonna get T by itself. So you divide by everything you don't want. I don't want the P, I don't want the R. And you're gonna do that on both sides. That's gonna eliminate the P and the R, and you're gonna be left with T all by itself. But then on the left side, now I have I over PR. And I can rearrange it and write it, flip it around so that I can write it in order. So T equals I over PR. Why am I looking for T? I wanted to isolate the T because that's what the question is asking for. If you read the question, it wants to know, find the number of years, right? So I'm looking for the years, and T represents the time in years. So since I'm looking for years, that's why I'm putting T by itself. All right. Once I have my literal equation, now I can plug numbers into it in order to solve. So I'm going to start with the equation just like it is. And then I'm going to figure out what's I, what's P, and what's R. This is where you guys have to read very carefully. So I want you guys to take 30 seconds to reread the problem and see if you can figure out which of those numbers is I, which of those is T or P, and which one is R. So I'm going to start by highlighting each one in a different color.
Wait,
What's up, Juan?
the I is, wait, the I is the 1,000.
So
Oh.
the
No. The I is the 5%.
So you're saying
The,
I is 5%, okay.
yeah. The P is, wait, let me reread it.
Yeah, mute yourself and reread it. You got some loud music coming from your, there we go. Okay, so anybody else want to guess or think about it? Alyssa's saying that R is 5%, okay. So let's go back to the original problem and see what it says about R. It says R is the rate at which interest will be paid. So R is a rate, and right there it says interest rate 5%. So yeah, that's correct.
The I is 600.
The I is 600. So it says I is the interest. I represents the interest. And then it does say interest totaling 600. So yep, this is my I, which means 1,000 is going to be my P, right? P is the principal or initial amount. And it doesn't really say those words, but you can think about it like they put in $1,000 and then from there it's going to get interest. It's going to grow. So this is my P. All right. So we know what each of them are. Now let's go ahead and plug them into the formula. So T equals, I is 600. So 600 divided by 1,000 times, here's the tricky part, R is 5%, but remember from the other day that you can't just put a percent inside a problem. You have to turn it into what?
A decimal.
Decimal.
A decimal, good. And 5% as a decimal becomes what?
0.05.
Good job. So this is 0.05, and that's it. Now we can do everything to get our answer. So the first thing we want to do is multiply the two denominators. So I'm going to leave that 600, and we're going to multiply 1,000 times 0.05.
50.
50, good. 50. Now we can divide 600 divided by 50.
12.
Good job. 12 what? What's our units? Read carefully.
Oh, years.
You got it. Nice job. Beautiful. Does anyone have a question? Anyone want to go over how to go from the 5% to 0.05? Because I know I kind of went through that quickly. Okay, all we did was move the decimal over. So there was a little mini decimal. We moved it over to the left 2 times and put a 0 in. That's how I went from 5% to 0.05. Anything else? Awesome. All right, so from here, what we're gonna do is we're no longer gonna be plugging in numbers and getting an answer. All we're gonna do from here on out is rearrange the formulas. So we're going to go through a few problems. This is the last one we're going to do together for now, because after this, I want you guys to try some by yourself. So let's do this one together, and then you'll have some time to do some by yourself. So the formula y equals mx plus b is the slope-intercept form of the equation for a line. Solve the equation for m. So we're trying to get m isolated. We're going to get m by itself. So I'm going to start off with just writing it down. I'm going to, just to make things very clear, I'm going to highlight the m just to make sure we remember which one we're trying to get alone. And now we're going to kind of treat this like an equation, because this one, there's two operations going on. There's m times x, but then we also have plus b, so we're also adding. So we're going to have to take 2 steps to solve this one, and this is kind of like a 2-step equation. So if you were doing a 2-step equation, what would you do first? Would you get rid of the multiplication or get rid of the addition?
Multiplication.
We get rid of the multiplication first?
Oh wait, yeah, it's backwards.
It's addition, exactly. We kind of want to think about it a little bit backwards. So before you can get rid of the x, first you want to get rid of the b. What operation can I use to get rid of my b?
Subtraction.
Subtraction?
Exactly. So I'm going to subtract b on both sides. And even though I'm subtracting on both sides, can I combine a y and a b?
No.
They're not like terms. So instead of putting them together, I'm going to keep them separate. So this is y minus b. Just like that. And then on the right side, my b's cancel out, so I'm left with mx. And this is literally just like a 2-step equation. Step 1 is the subtraction property. And what would step 2 be?
Division property.
Good, you got it. We're going to divide because m and x are being held together by multiplication. This is technically m times x. So to get rid of the x, we're going to divide because that's the opposite. So I'm going to divide by x. On the left side, do I divide by x only to one of those terms, or do I do it to both of those terms? I see Juan holding up a 2. Yeah, both. You always do it to both. So I'm going to divide everything by x. So what does that do? My x's cancel out. On the left, I have y minus b over x. And on the right, I've got my m all by itself. Just to write things in the correct order, I can just flip it all around. And this is m equals y minus b over x.
I'm confused how it works because I seen it, but what?
That's a good point. I think I know what I can do to help you out. So I'm going to leave this just like it is, but I'm just going to make things a little bit smaller. Okay. I'm just going to erase these over here. Okay. Cool. So you do not need to write this. Everything I'm about to do, you do not need to write, just watch. So I'm going to do a very similar problem, but I'm going to make it with numbers instead. Okay, let's do that. Okay, so this is a two-step equation. It's very, very similar. So I'm going to keep things organized. What am I trying to get by itself in this two-step equation?
The m.
Still getting the m by itself, right? And I'm actually going to change this to a 7. Okay. All right, so if I'm trying to get the m by itself, what's the first thing I got to do?
Subtract the 7.
Good. Subtract the 7 on both sides, right? Notice how I'm doing the same thing so far as I did in the first problem. That means my 7s cancel out. Now, I can do it in my head. I could do 4 minus 7 in my head and get an answer, but just to keep things looking the same, I'm just going to write 4 minus 7. Later on, we'll do it in our head. I'll show you why. The only reason I'm doing this is to show you the similarities. If I'm getting m by itself, what do I do now?
Divide?
Divide.
I would divide by 3, right? This would eliminate my 3, and I would be left with m equals 4 minus 7 over 3. Okay, so notice how right now, in step 1, for both of these, it was the same thing. I did the subtraction property. For step 2, same thing. I did the division property. Right? The only difference between these two types of problems is that with literal equations, you just have a bunch of letters. You're just moving the letters around. But with actual equations that have numbers in them, if it only has one variable, you can get a final answer. So here I can get my final answer. So I could do what's 4 minus 7?
-3.
And then -3.
-3.
And then I've got a denominator, right? So now I have to do -3 divided by 3, which is
1.
And I had a negative divided by a positive. So that's going to be
Negative.
-1, right? The only difference between these two problems is that I can get a final answer on the right side. But I followed the same steps. I got m by itself, and I got an answer for both of them. It's just that with my literal equation, my answer looks like a bunch of letters. And with my normal equation, my answer looks like a number, a final answer. Does that kind of clarify things a little bit? Kind of understanding? Okay, cool. Alrighty, let's do, now you guys are gonna take a couple minutes and work on these 3 by yourself. So I'm gonna give you guys not too much, I don't wanna use too much time, but let's do 7 minutes.
Do we send you the answers?
You can send me the answers. It might be a little hard to send me the answers because it'll look like math. So I don't know if you'll be able to do it easily, but you can try sending me your answers, yeah. 7 minutes, take your time, work it out. Remember to follow those steps very clearly and see if you can figure it out. About halfway through. About 1 more minute left. All right. All right. So I got some really good answers in the chat. I'm seeing it looks like those of you who are sending answers, you guys are doing really well. So if you did not send me an answer, I'm assuming you're a little bit confused, and hopefully this will help make sense. So starting with number 1, I'm trying to solve for r. So I want to get r by itself. What is holding on to the r right now?
The 2 pi.
2 pi. And what operation is holding it to the r?
Multiplication.
Multiplication. And how do we undo multiplication?
By dividing.
By dividing. Good. So all we need to do to get rid of that 2 pi is divide by 2 pi. And since we're doing it on the right side, I also have to do it on the left. So that eliminates the 2 pi, and I'm left with r equals c over 2 pi, which you can rewrite the other way around, r equals c over 2 pi. That one was very similar to the first one we did. That was the volume one that we did together. Any questions?
Y minus B over.
All right. That was number 1. Let's kick it up a notch. Number 2 is definitely a little trickier. I'll write it over here. So now I have A equals 1/2 BH. And we actually mentioned, somebody mentioned this at the beginning. This is the area of a triangle. So we're going to solve for B. I want B to be by itself. And what do we see in this problem that we want to get rid of immediately? What goes first?
The fraction.
The fraction, exactly. And how do I get rid of a fraction?
By multiplying it by its denominator.
Exactly. And so since I have 1/2, I basically want to multiply, want to multiply, let me move this over, by 2 on both sides. So 2 over here and 2 over there. Now, what this does is it gets rid of the fraction. So I actually, you know what, I'm going to move things around a little bit just to make this a little clearer so I have a little more space. Okay. So let me actually rewrite that. There we go. So I'm going to multiply by 2 on the left and on the right. And since I'm doing it on the right, this eliminates my fraction. Because what is 2 times 1/2?
1.
1. So this basically turns it into a 1. It eliminates it. On the left, now I have 2a. And on the right, I have bh. So we're trying to get b by itself. So very similar to the previous problem. What's holding the b and the h together?
Multiplication.
Good, multiplication. So to get rid of it, I'm going to divide. Oh wait, I'm getting rid of the h, my bad. There we go. Divide by h. This way I can eliminate it, and then I have b equals 2a over h. Flipping it over to write it the other way around, and I have my answer. Let me box these. All right, any questions so far? I know that number 2 is a little trickier, so I hope that clarified it for anyone who was confused. Cool. Why do we flip it around? I just flip it around because when you read it, it looks better when you have the isolated variable by itself first. So instead of, before I flipped it around, this would be 2a over h equals b, but I want it to say b equals 2a over h. So since I read it from left to right, I just want it's just how I like to write it better. They're both correct, but when you flip it around, it's just a little more clear. All right, I'm going to erase number 1 so that I can write down number 3. And this one was very, very similar to the one we just did. It's just that it wants you to solve for x instead of m. But the steps are pretty much the same. So what should I do first?
Get rid of the b.
Subtract.
Good, subtract by b. Do I combine them or leave them separate?
Leave them separate.
Good, we're gonna leave y minus b separate because they can't combine. This time I'm solving for x, so what should I divide by on both sides?
M.
Good. And you divide everything by m. So this gives me x equals y minus b over m. And just to flip it around to make it look nicer, that's going to be x equals y minus b over m. So these are kind of like the basic ones. These 3 problems are pretty basic. This is like, make sure you know how to do this so that in the next problem you're going to see, we're going to do a couple challenge problems. we can apply the same exact process to a slightly more difficult problem. So do I have any questions before we move on to a slightly harder question? Okay. Okay. So we're solving for x, right? Before we go through it, this is with all my challenge problems, I always like to write down what issues I'm going to have to deal with. So what issues do we see?
Division.
Division, and it has the bar, so I'm going to write this kind of like a fraction, right? And there's one more little issue. If I'm solving for x, what might be a problem?
Addition.
There's two x's.
There's two x's, yeah, they're being added. There's two separate x's. So we're gonna have to find a way to put them together. That way I can have just one by itself. All right, so just like most of the problems we ever do, which of these two issues should I probably solve first? This is not a trick question. This is just like any other problem. What do we always deal with first?
Addition.
The fraction.
The fraction.
Fraction.
Oh.
Remember, fractions are your worst friend. We want them out of the way. Okay, and just like before, we always multiply by the denominator. So all I'm gonna do is multiply by 2 on both sides. When you do that, it eliminates the fraction, so it gets rid of the denominator. And then on the right side, it's just gonna be 2a. Okay. Now we have to figure out how in the world am I going to get these two x's to turn into 1? Because we need to solve for 1. We need to have it be all alone. So the way that we do this is what I like to call, here, let me write down step 1 just to be clear. Step 1 was to multiply. Step 2 is what I like to call opposite of distribution. So the opposite of distribution. And I'll show you what that means. When you distribute, let's just look, you do not need to write this down, but just as a little example. When you distribute, it looks like this, right? And you multiply to the inside. So this would become 3x plus 6, right? Pretty simple. What if my problem looked more like this? What if it was x on the outside and the b and the c on the inside? When you distribute, this becomes, we're doing b times x, so that's bx, and then c times x, so that's cx. It's the same exact thing, it's just that instead of using numbers, I'm using all these letters. And notice that's what I have exactly right here, right? So when you notice that you have two variables and you need to turn them into one, just like this, I have bx and I have cx, what you can do is the opposite of distribution. So basically, I'm going to leave the same thing on the left. Basically, what you do is you take the x out. It's like you kick him out. You're going to leave him outside at the door, and everyone else can stay inside. We didn't want that x at the party. I don't want my x's at the party. So I'm going to kick him out, leave him outside at the door, and everybody else can stay. This is a little bit, if you've never done this before, it takes a second to get used to it, but does anybody have any questions about this? That is sad. Why would you do that? I'm doing it because I need the x to be all by itself. So I just went from having two separate x's to having one x all by itself. Questions? No x's. We don't like them. Cool. We have one step left. We want to get x all by itself, and what's holding the x to the b plus c? What do those parentheses tell us? What operation is happening here?
Multiplication.
Exactly. This is the same thing as x times b plus c. So to get b plus c out of the way, all I need to do is divide. The opposite of multiplication is division. So I'm dividing by b plus c. We're going to keep them together because they're just staying together. And I do that on both sides. So my final answer, I'm going to cross this out, is x equals, and I'm kind of flipping it in my head already. Instead of writing it down, I'm flipping it in my head, but I have x equals 2a over b plus c. And those parentheses, you can keep them, but since there's nothing else in the denominator, you don't really need them there right now. So I'll go over your homework at the end, but you will have homework on this, and the homework does have a couple of problems with opposite of distribution. So we'll have one more practice problem to go over it one more time, but just so you know, you do need to know how to do this in order to do the homework, okay? So if you have any questions, it's very important that you ask them.
My headphones had cut off for a second, so I didn't hear the last part where you were saying of the distribution thing.
I was just saying that there's a couple of questions on the homework.
No, not that, like when you were doing the opposite thing of distribution.
Oh, okay. We'll do one more problem that has the same thing, so I'll explain it again in the next problem. Sound good? It's the same.
Miss, are you gonna post this video?
Yes, ma'am. I always post them at the end of the day, okay? So if you're ever worried, you can check at the end. After like 4 p.m., it should be up. Okay. Let's do one more. Just like I said, we're going to do this backwards distribution one more time. So again, I have a challenge problem. I always start off by writing down what I'm going to need to solve. Just like previously, I'm going to have to turn those 3 y's into 1, right? So I have multiple y's. So I'm going to have to figure out how to turn them into 1. But there's also one more slight issue. Does anyone notice it?
Addition.
There's addition. That's not really a huge problem. We can figure out addition. Negative. That's easy. Negative, that might be a little bit of a problem, but
There's a constant or something.
Okay, the constant might be a problem. You're almost there. So
Variables on both sides.
there it is. Not only do I have multiple y's on the same side, I have y's left, right, center. They're everywhere. So I need to figure out how to get them all to one side. So variables on both sides. Okay, it's like crazy. It's all over the place. So we're going to start off with, before I do the backwards distribution like I did before, I want to make sure they're all in the same side in order to do that. So to get them all to the same side, what should I do first? Think about your inverse operation. If I want to get my y's all to the left. Good. I see Alyssa put it in the chat. So I'm trying to get this guy, move him over, right? He's negative. It's a negative 4y. So the opposite of negative is positive. I'm going to add 4y. Okay, so I'm going to add 4y, which allows me to cancel it on the right side. Now, can I combine anything?
Yeah.
Are there numbers, are there other numbers that I can add 4 to? Are there any other numbers? I see PY, QY on the left side.
Oh.
Right, and there aren't. So you can't combine it with anything because there's nothing to add it to. So I'm going to keep everything separate. So this is PY plus QY plus 4Y, all separate, equals 8. All right, now here comes the part where I'm going to kick Y out of the party. All right, we're kicking the Y out because that's the one I want to get by itself. It's kind of like, okay, if you're at a party, which you guys shouldn't be at, but if you're at a party and you want to have a word with the Y because the Y is causing trouble, you want to get him alone so you can have a word with him. You got to get him outside because you don't want to have a whole argument inside where everybody's having fun, right? So we're going to kick him out. We're going to step outside and we're going to have a little argument, a little conversation with our friend, Mr. Y. So first things first, you got to kick him out. That Y, he comes, there's 3 of them, right? There's 1, 2, 3. Okay, we're going to kick him out first. And everybody else gets to stay inside and have fun. So I have a P, I have a Q, and I have a 4. And they all stay together. And we're good. The 8 stays by itself. Everything else stays the same. Any questions on the backwards distribution? Awesome. Okay. So step 1 was addition property. Step 2 was we kicked him out, backwards distribution, and there's actually a word for this. It's called factoring. That's all we did. We factored out the Y. Now that he's all alone, wherever he is, in the backyard or wherever you're going to go talk to him, we can now get the P, the Q, and the 4 out of the way. So what operation should I use to eliminate the P, the Q, and the 4?
Division?
Division, exactly. We're going to divide by P plus Q plus 4 on both sides. That eliminates that whole entire thing. So my final answer is Y equals 8 over P plus Q plus 4. Okay, so any questions on factoring, aka backwards distribution, aka kicking Y out of the party?
No.
Cool. Alrighty. It is 10:20. I think we have one more problem, one more challenge problem, and then that'll be it. Okay, so let's go ahead and do the last one. Okay, and for this one, it's multiple choice. So this is kind of what it would look like on a test. The nice thing about multiple choice is that if you're stuck, you can kind of see what the answers might look like. So you can, if you're stuck, you can see, okay, maybe I can figure out how to make it look like letter C. So let's go ahead and look. The formula shown can be used to find A, the amount of money Raul has in his savings account. Raul wants to find R, the rate of interest his money earns. Which equation is correctly solved for R? So we want to isolate the R. I'm going to highlight it so we can keep track of where it is. And who would like to volunteer? Let's see if we can do this all. I want to hear what you guys have to say. I'm not going to say anything. You guys tell me what to do first.
Can you combine like terms?
Good question. So which like terms do we see? We see a P and then we see PRT, right? So maybe there could be a way to combine the like terms. But remember, what are you trying to get alone? You're trying to get r by itself, right? In order to get r by itself, I don't know. Let's see, what can we get rid of? We want to get things away, not combine.
Like P, right?
Yeah, the P. The one that's kind of on its own right now, this one?
Yeah. Yeah.
That one can move first. And what operation can I use to get rid of him?
Subtraction.
Good. We're going to subtract by P. Good job, guys. So minus P and minus P. How did I know to use subtraction and not addition?
Because there's a plus sign in front of it.
Right. The P is positive because
Yeah.
there's kind of like an invisible plus sign in front of it. So the opposite is to subtract. Okay. That gets rid of the P. Now I can't combine these, so it's just going to be A minus P equals P R T. Okay. Now I can get rid of everything else. And what operation should I use to get rid of everything else?
Division.
Division, exactly. Since this is P times R times T, the opposite of multiplication is division. And you can divide by everything you don't want. I don't want the P or the T, so they can go away. And that cancels out everything I don't want, which leaves me with R by itself. And I have A minus P over PT. What answer choice is that?
D.
That's answer choice D, exactly. And this was basically a two-step equation. Step 1, subtract. Step 2, divide. Just a little more complicated because it's a bunch of letters. But it's still following the same rules, just like we did at the beginning. So do I have any final questions? All right, cool. So for homework, like I said, I will be giving, I already posted it actually. So I posted it on Khan Academy already. This one is due on Wednesday. So usually I've been doing it for Friday, but this one, make sure you know it's due Wednesday, okay? And when you're getting this done, it is very, very important, something that you might not know. So I'm gonna show you right now. Give me 1 second. Okay. When you're working on your Khan Academy, you can have more than one try. So if this was literally the same problem I just did, and you're working on it, and let's say you get it wrong, right? So let's say you just, I'm gonna put something random, -2. That's gonna be wrong, right? Okay, so it says not quite, try again. At this point, when you get it wrong the first time, it counts as wrong no matter how many times you do it. So even if you try again and you get it correct, it's still gonna tell you that you got it wrong as your final grade. So what you should do, if you get a question wrong, first of all, you can get help and you can read their strategy and see if that helps you out to understand it. But since you already technically got this wrong, instead of continuing to the next problem, something I suggest is moving on, put something random for everything. Just keep going, put something random, keep moving on, random, move on, random, move on, doesn't matter. Okay, it's gonna say I got a 0. And when it tells you you got a 0, you can try again. So the second time around, now you're gonna try it again and try and get everything correct. So the reason I'm saying this is because instead of trying it again while you're instead of trying it again the first time you look at that assignment, it's better to do the whole assignment again so that you can get a chance for a better grade. Does that kind of make sense?
Cheating.
It's not cheating. It just gets you a better grade. I don't know. I'm telling you to do it, so don't complain.
Yeah, why are you complaining?
So anybody have any questions?
I need the class code, miss.
Oh yeah, Bianca, I need to add you. Okay, I'll send it in the chat real quick. Any other questions? Lauren, yeah, I will remind you for sure. I always try to remind you whenever you have an assignment due. Any last questions though?
We're allowed to try as many times as we want, right?
As many times as you want, yeah.
Okay.
Since it's a homework assignment, homework is all about learning and improving and learning from your mistakes. That's why I'm telling you, you can cheat. I'm not saying it's cheating. I'm just saying that that's a strategy you can use to improve and learn and keep working, okay? What's up, David?
So you want us to cheat?
It's not cheating, it's a loophole.
It's a loophole, exactly. It's not cheating because the next time you do it, it's going to give you a whole new set of questions. So it's not like you're doing the same question again. You're just doing a similar question, and now you know how to do it correctly.
But if you do it like a lot of times, it might give you at least one or two of the same questions.
There you go.
And then I might know it, but I'll let you know though.
Okay.
It's not cheating if the teacher tells you to.
It's not cheating. Sure.
All right, you guys. So any final questions? Bianca, I just put the link in the chat so you can go ahead and click on